Today I'm going to talk about face recognition. Now there is a new concept called Industry 4.0. The term Industry 4.0 originates from a project in the high-tech strategy of German government, which promotes the computerization of the manufacturing industry. Pattern recognition and machine learning play an important role in it. We should have the ability to identify objects and decide what to do next. And we want to start from an easy part, face recognition. To recognize a face, we should have the ability to deal with the original pictures and train the whole system to match the faces. Now there are so many algorithms can do that. We choose principal components analysis to deal with the original pictures, and we choose support vector machine to train the system. First, we will talk about how PCA works. It is a statistical procedure that uses orthogonal transformation to convert a set of observations of possibly correlated variables into a set of values of linearly uncorrelated variables called principal components. This transformation is defined in such a way that the first principal component has the largest possible variance, and each succeeding component in turn has the highest variance possible under the constraint that is orthogonal to the preceding components. The principal components are orthogonal because they are the eigenvectors and the covariance matrix which is symmetric. So we input a picture and then we will have a matrix. Each row represents a symbol and each column represents a number of the dimensions of the symbol. And after PCA we get k-dimensional eigenvector of the symbol. And now we will find out how to train the system. In machine learning, support vector machines are supervised learning models with associated learning algorithms that analyze data and recognize patterns, used for classification and regression analysis. Given a set of training examples, each marked as belonging to one of two categories, an SVM training algorithm builds a model that assigns new examples into one category or the other, making it a non-probabilistic binary linear classifier. An SVM model is a representation of the example as points in space, mapped so that the examples of the separate categories are divided by a clear gap that is as wide as possible. New examples are then mapped into the same space and predicted to belong to a category based on which side of the gap they fall on. So now we get two important algorithms. What we need next is a database of faces and the codes of algorithm. Thanks to AT&T, we have a database of faces, and consider MATLAB has a machine learning toolbox, so we decided to use MATLAB to train the system. And before I show you the program, I will talk about how the program works. First, we deal with the simple data and test data with principal components algorithm, and then we train the system. And at last, we compare the data to get the answer. And we will talk about the detail of scaling. For example, why we need scaling and how to scale the data in the report. So next is the program. First, we test the whole accuracy of the data to build an SVM database, and then we choose a picture to recognize it. Now the computer is training the data. So we got the answer that accuracy is 83.5%. Now we select a photo. choose this person and we start. So now we get the answer. This person is the 31st person in the database. And back to the slides. And now the problem is this program is not perfect. It spends a lot of time to calculate the result and it can only recognize simple picture. So we can try to speed it up to be more efficiency and improve the program to recognize different things. So that's all. Thank you.